quadratics. And today we're talking about something with a funny word, a funny name. It's called a discriminant. A discriminant is going to help us figure out which method we want to use and like how much work are we going to have to put into this thing to figure out our x-intercepts. So when you use a discriminant, and you're going to have to use it on the homework today, it's connected to this idea of which method is best. And I like to think about it like this. How do we get these different solutions? Or not how, but why? Why do sometimes we get no x-intercepts? Why do sometimes we get 1? Why do sometimes we get 2? If you think about that, then you're already starting to think about a discriminant. A discriminant tells you how many solutions you're going to get. Are you going to get none? Are you going to get 1? Are you going to get 2? Who knows? Well, the discriminant knows. Well, I just made that up. Who knows? The discriminant knows. It knows how many answers you're going to get. And when we talk about discriminant, you have to talk about the quadratic formula. They go right together. They're kind of made from each other. And a reminder, this is the quadratic formula. I think it's probably worth writing it down again, just because the more you write it down without numbers in it, the more you remember what it is. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So we know that we can get these different answers. We know that no x-intercepts happen because the quadratic isn't touching the x-axis. It's either moved way up to the top or way down to the bottom, or it's curving in a way that's just not going to touch. We know we get 1 because the parabola hits the x and bounces right off, either from the top or from the bottom. It just touches and goes the other direction. We get 2 a lot of the times because the parabolas are going to cross. Now, in this quadratic formula that we used last time, we saw, and actually saw in the homework, that you can get no x-intercepts from it. You can get 2 x-intercepts from it. And in our lesson that day, we actually found that there is a way you can get a 1 x-intercept as well. Now, if you think about why do we get no x-intercepts from this equation, the reason has to deal with this square root. If you can't take the square root of a negative, if it tells you to take the square root of a negative, you're going to get no answer, no x-intercept. You get 1 x-intercept. It's actually kind of interesting. There's only one way you get 1 x-intercept from the square root. This has to be a 0. 0 is the only number that only has 1, that when you take square root, you only get 1 answer. Is that weird? 0 is the only number that has 1 answer for a square root. And then you get 2 x-intercepts all the other times. So the discriminant is this. Let's see, where do I want to write it? I'm going to write it over here. The b squared minus 4ac. The discriminant is the piece of the quadratic formula that's underneath the square root. Because the quadratic formula is so awesome and so powerful and knows how many intercepts you're going to get, if you do b squared minus 4ac, that piece in the square root here, if you do that and you get something that's less than 0, you're going to have no answer because you're not going to be able to take the square root. This works all the time, even if you're not using the quadratic formula. If you do b squared minus 4ac, it's going to tell you if you're going to have an answer or not. If it's a negative number, you're not going to have an x-intercept because you can't take the square root of a negative. So if you already know that there's going to be no answer, why go through and solve it? The answer is don't. If you find out you're going to have no x-intercepts, then all you need to do is tell us why. And if the discriminant tells you that it's going to be a number less than 0, that means a negative number, then you know there's going to be no x-intercepts. So you can't take the square root of a negative. If you do b squared minus 4ac, and you find out that that answer is 0, well, that means that in the quadratic formula, you would take the square root of 0, which is going to give you one x-intercept, because you're going to have some number plus or minus 0. Well, if you add 0 and you take away 0, you get the same number. Isn't this cool how powerful the discriminant is? And the last thing would just be what's left over. We talked about everything less than 0, everything equal to 0. Well, if you go b squared minus 4ac and you get something greater than 0, then that means you're going to have two answers. So I like the discriminant because it saves algebra students a ton of work. And algebra 2 teachers, not algebra 1 teachers, algebra 2 teachers love to give you really hard problems that a lot of students will just jump in and solve. But if you do the discriminant at the beginning, you might see that there's no x-intercept. If you can figure that out, then don't solve it. Just tell us that there's going to be no intercepts because of the discriminant. It's kind of cool. So we're going to try using b squared minus 4ac, and we're going to see what the result is. Let me show you an example. I'm going to slide this up. And this is what your homework is going to look like today. You're going to be given a problem, and you're going to use a discriminant to figure out if you should solve it or not. And then if you should, then you'll go through and solve it. So it might look like this. We'll call this number 1. 3x squared plus 2x minus 4. And you know what? I'm going to set it equal to 0 right away for us. Just like when you're using the quadratic formula, when you're using the discriminant, you need to tell us what your a, b, and c are. A is 3, b is 2, and c is negative 4. And then what we want to do is we want to figure out what do we get with the discriminant. So what do we get if we go b squared minus 4ac? Well, let me see. My b is 2. So I'm going to have 2 squared minus 4 times 3 times negative 4. And now it's just an order of operations problem. 2 times itself is 4. And then we have negative 4 times 3, which is negative 12. And negative 12 times negative 4 is positive 48. So we're going to have 4 plus 48, which gives us 52. So is this going to have any x-intercepts when we solve it? You have to go back here to what we put in our notes. We got an answer that's greater than 0, so that means we're going to have 2 solutions. So now we have to go through and use a quadratic formula. If we got 0, we'd still do the quadratic formula, but we know we're going to get one answer. If we got some negative number, then we won't even bother doing anything else with the problem. At this point, we would just say no x-intercepts and move on to the next one. Okay, but we got a 52, so we have to solve it now. And that's what you'll do in your homework. If you get one that has a solution, you'll have to solve it. So let's see if we can remember how to solve this. We use the quadratic formula, which is up there at the top. And the first step, well, is to write a, b, and c, which we already did. Then the second step is to plug them in. So x is negative 2 plus or minus the square root. Hey, wait a minute. Didn't we already do b squared minus 4ac? So save some work. Tell us what it is. It's going to be 52. That's the other cool thing about discriminant. Is if you have to then solve the problem, you already did some of the work. Divided by 2 times a. Okay, so now we're going to do the multiplication on the bottom. X is negative 2 plus or minus the square root of 52 divided by 6. And then if you remember, this is a point when we split it apart. We're going to add the square root of 52 and subtract the square root of 52. So x is -2 plus the square root of 52 divided by 6. Or x is going to be -2 minus the square root of 52 divided by 6. My favorite part of the discriminant is not only does it tell you at the beginning if you need to solve the problem or not, but then if you do have to solve, we get to just plug it right in right there because it's part of the quadratic formula. That's so neat. And now I'm at the point, I'm just going to plug this into my calculator and see what we get. So -2 plus the square root of 52. I find out what that is. It's almost always some bad looking decimal. Okay, thanks, Segal. Thanks for letting me know. And then we have to divide by 6. Divide by 6. Okay, so rounding in the nearest hundredth, that's about, let's see, the 6 is going to say 6 will go up to a 7. Well, the next digit's an 8. So this is going to be 0.87. X is about 0.87. And then we do it again. -2 minus the square root of 52 is another bad looking decimal. Divide by 6. So let's see, the 3 is either staying a 3 or going up to a 4. It's going to go up to a 4 because the next digit's a 5. So about -1.54. X is about -1.54. And we put the word or in between and we box our answers. You don't have to write them in ordered pairs anymore. We know these are x-intercepts, so you just leave it like that. The quadratic formula is the best and the worst thing. It's a lot of work, but it's also a lot of power. You don't use it every time like we saw in that activity with the cards. You use it some of the times. On your homework today, though, every problem I give you, you need to use a quadratic formula. They're not good for factoring, they're not good with square roots. It's going to be quadratic formula. But what you're going to do is you're going to do the discriminant first to figure out how many answers you get. And if you have answers, then you find them. If you don't have answers, then tell us that there aren't going to be answers. Okay? Good? Okay, so I have one other thing to share with you. So today we're practicing the quadratic formula and practicing the discriminant. The most common problem are just simple mistakes students make. That's the thing. At first, there's a lot of wonder, like, what does this mean and how do I use it? But we're past that now. What comes up now is a lot of people just making kind of like, not silly mistakes, just kind of common mistakes. So I'm going to show you a couple examples with mistakes. I want to see if we can find them. After we do this all together, I'm going to send you off and you're going to do it on your own. So make sure you're listening and following along with what we're doing here. Okay? So this was the same problem we just did in our notes. But this person has a mistake somewhere. Look through. So they copy down the problem correctly. They tell us the A, B, and C, but look through. See if you can find their mistake. And can anybody let me know once they find it? This is the first very common mistake someone would make on this. I've seen this mistake made so many times. Addison found it first. Look at the second step. Let me see if I can draw on this. Yep, you found it, Addison. Right here on this line here, the mistake is right here. What's that number supposed to be? -4. She does all the math right after this. She multiplied the 4 and the 3, then she multiplied the negatives here. But This should have been a -4. This would have been a -12, and then this should have given her a positive. So that one little mistake ruined the whole rest of the problem for her. And that's in the discriminant part. So you might make that mistake when you're doing your discriminants today. Please don't. Be very careful substituting in the values. Okay, let's look at another one. So we've told the student what they did wrong. And then a common thing that happens is they fix it, they go back through, and then they make another mistake somewhere. So same student, same work. Again, there's a mistake somewhere. Look through, see if you can find it. They fix that mistake from before. They used a -4 this time. Ethan, I see your idea. Can you put a little bit more in the chat so I know a little bit more about that? Cooper, you find it?
Yeah, a negative times a negative.
Say it again, a what?
A negative times a negative.
Nice. Yep. Yep. I think actually Ethan found it right before you. So Ethan found it, Cooper found it, Natalie, Addison, good. Yep. So it is right there. I guess we would say the problem was probably right here. When the student multiplied that, they should have had a positive 48. Like you were saying, a negative times negative is a positive. So don't make that mistake today. Again, that's in the discriminant. Okay, so be very careful. That's why we do it one step at a time, so we can find these mistakes. Okay, one more, and then I will send you to your homework. I think these are kind of fun to look through for these mistakes. Same student, went through, solved it, they have a mistake. See if you can find it. They took all of our advice so far, they're making all the right changes. Oh, Ethan was the first one to find it. I'm gonna give everyone just a little bit longer, see if they can find it too, Ethan. Well done. Well, actually, I don't think that's a mistake. Let me check real quick. No, Ethan, that's not their mistake. That is a common one, though. Addison and Maya got it at nearly the same time. The mistake is in the rounding. Ethan found another one too. This student should have written like this division sign under everything. But in their answer, they did divide by 6, but they made a mistake in rounding. This should have rounded up to a 7 because what came after it? An 8. It was 0.868. So they should have rounded that to a 7. And then this other one was negative 1.53. And the thing that came after the 3 was a 5. So they should have rounded that up too. Okay, so be careful with your roundings, be careful with your negatives, be careful with plugging in values. Any questions or concerns with any of those? Like I said, these are the most common mistakes. Other mistakes are made too with quadratic formula, but these are the ones that most students will make. Okay. So let's see. To get to your homework today, you actually have to do a little bit of typing first. In the chat, I'm putting a link to some common mistakes. They're actually the ones we just looked at. You click that link, it's going to take you, let's see, it should